All right, folks, starting off with Chapter 2, we're going to start learning about atoms and atomic structure. We're going to need to learn about 3 different particles or parts that make up the atom. So we've got atomic parts, and we need to know a little bit about their characteristics. So the 3 parts of the atom are the proton, the neutron, and the electron. And we characterize these by their mass and their electric charge and their location in the atom. So we'll start here with mass. The proton and the neutron both have a mass of 1 atomic mass unit. Well, what is an atomic mass unit? Well, let me write it up here. 1 AMU, in case you're wondering, is equal to 1.67 times 10 to the negative 27 kilograms. It is tiny. These things are really, really small. We're just going to count them as 1. So the proton has a mass, we'll say, of 1, but it's 1 atomic mass unit, which is that size. And a neutron also has a mass of 1 atomic mass unit. The electron, it has mass, but it's like 1/2000th the mass of these. Really tiny. I'll write the mass up here in case you're interested. The mass of the electron, M sub E, is going to be 9.1 times 10 to the negative 31 kilograms. So that's our mass of the electron. It's like, 10,000, well, it's actually about 2,000 times smaller than these. So for the purposes of this class, we're going to say that the electron has a mass of 0, even though it does have some mass. The electric charge of these particles, the proton, which begins with P, is positive, which begins with P. It has a charge of positive 1. These are elementary charge units. What is that charge? Well, that's 1.602 times 10 to the minus 19 coulombs, where coulomb is your unit of charge. Very tiny charge. The neutron is neutral. It has no charge. And the electron has an electric charge of -1. And what does electric charge mean? Well, we really only know what it is by doing experiments. If we take a positive charge and a negative charge, the law of electric charge tells us that those electric charges will attract. Opposite charges attract. So a proton with a charge of positive 1 is going to attract an electron which has a charge of -1. Opposite charges attract. What about like charges? If I take a positive proton and another positive proton, I try to stick them together, well, like charges repel, so those are gonna fly apart. If I take an electron and another electron, I stick them together, same thing. Like charges repel, so electrons repel electrons, protons repel protons, but a proton and an electron, those are going to attract one another. I just want to pause here and emphasize this law of electric charge. It's an important law that we use a lot in chemistry, and it describes a lot of things that we see. So make sure we understand the law of electric charge. Opposite charges, positive and negative, attract. Like charges, positive and positive, or negative and negative, those are going to repel. Neutral, however, a neutron, those show neither electric repulsion nor electric attraction. So a neutron and a neutron, if you stick those together, nothing's going to happen. They're not going to fly apart. They're not going to stick together. Same thing's true, though, if I take a neutron and a proton. Nothing will happen. There's no charge on that neutron, so it shows neither attraction nor repulsion with a proton. Same thing with a neutron and an electron. Neither attraction nor repulsion there. Where are these located in the atom? The neutron and the proton, they are found in what's called the nucleus of the atom, or the center of the atom. And the electron is found outside the nucleus. whizzes around the outside at very, very high speeds. So you've probably seen a picture of the atom on TV. Maybe you watched Jimmy Neutron when you were a kid. It looks something like this. You'll see positive protons and maybe uncharged neutrons in the nucleus or the center of the atom. And whizzing around the outside, you'll see electrons. Something like this. And this is okay to think about the atom like this. It's going to work for this chapter. There will become a part in this course where we don't want to think about the atom this way anymore. The atom is much more mysterious and interesting than this. But nevertheless, this sort of model of the atom is often useful, and for now we're going to use it. Notice the proton, which is positive, it's in the nucleus or the center. The neutron, which is neutral, that is also in the nucleus or the center. And the electrons, we can think of them as orbiting around. But this isn't right, I'm lying to you, but nevertheless, for now, we can think of them as orbiting around or speeding around the outside, and those have negative charges. So you should recognize that almost all of the mass, because both of these have both of these have mass, almost all of the mass of the atom is located in the nucleus. Because remember, these are really, really tiny in terms of mass. So the concentration of mass is in the nucleus of the atom. All right. Let me see what I got here. Did law of electric charge. All right, we're going to look at some symbolisms for atoms, ways that we symbolize them. So you probably noticed when I wrote water, I used an H to symbolize a hydrogen atom. I used an O to symbolize an oxygen atom. I used a C to represent a carbon atom. Where do we get these symbols from? Well, they're designated, and if you look on the periodic table of elements, you'll see that each square on the table represents a particular element, which is made of an atom, and that particular atom is identified by its atomic number, which we call Z. The atomic number. It is the identifying characteristic of an atom. And all it represents is the number of protons. The number of protons in the nucleus of an atom. So like hydrogen, if you look at hydrogen, you'll see on hydrogen space, you'll see a 1 up above, and then you'll see an H, and maybe you'll see its name, and then down here you'll see a 1.0079 down below. This is the way we often symbolize hydrogen with a capital H. This number up here is Z. That's the atomic number. And what that tells me, by definition, if I have an atom with 1 proton in its nucleus, that's a hydrogen atom. It might have all sorts of different stuff going on in terms of electrons and neutrons, and we'll learn about that in a bit. But if I have an atom, a particle, that's got 1 proton in its 1 proton in its nucleus, we call that hydrogen. If I have a particle that has 2 protons in its nucleus, its atomic number is 2. Well, I look on the chart for the atom, or the element, with an atomic number of 2, and that's helium. 4.0 something, I can't remember the rest of it. Notice that when we write an atom symbol with letters, the first letter is always capitalized, H for hydrogen, H for helium, and the second letter, if there is one, there's not a second letter in hydrogen, but that second letter in helium is lowercase, always written lowercase. And that's important because if we look at the element cobalt, I don't want to write cobalt like this. I don't want to write C, capital O for cobalt, because this actually means carbon monoxide. to a chemist, this represents a molecule in which you have one atom of carbon and one atom of oxygen hooked together in a molecule. Cobalt, you have that capital C for the first letter in the element. That second letter, if it's there, is always going to be lowercase. So make sure you pay attention to that. Okay, so we've got the atomic number, Z. You may also see, well, I'll just write X. We'll just make X the chemical symbol, which I just talked about, right? The first letter is always capital. The second letter is always lowercase. So this is going to be the chemical symbol. We also have A, which is what we call the mass number. Let's see, the mass number in an atom. Where does the mass come from in an atom? Let me ask it this way. Which particle in the atom does not have mass? That's the electron. So the mass comes from the other stuff, which is the protons and the neutrons. So the mass number, that's going to be the number of protons plus the number of neutrons. That's going to tell us the mass of the atomic particle we're dealing with. Then we can say C, that's just going to be the charge on the atom or ion. Well, the charge can either be positive if you have an excess of protons, because protons are positive, or it can be negative if you have an excess of electrons, because electrons are negative. So the way we calculate the charge, this is going to be the number of protons minus the number of electrons. And so I can put all of this together in the following way. Let's see. What we often do is we'll write the symbol for our atom like this, and then we write the mass number up here as a superscript to the left, and then down here we write the atomic number as a subscript to the left, and then up here we put the charge as a superscript to the right. So let's say, for example, I have this written. That contains all the information of all the particles that exist in this particular atomic particle. These had always better match. I mean, I don't have to write that there. By putting the symbol, I've already told you the number of protons that the substance has. But nevertheless, sometimes they stick it in. Okay, so what is this? Well, let's say I want to know the number of protons, neutrons, and electrons in this particular substance. Okay, so the way I do this is, since I have hydrogen, I know there's one proton. There's got to be. Let's see, protons, neutrons, electrons. So protons, that's going to be 1. My neutrons, well, look at this. This is protons plus neutrons. This is my mass number up here. And down here, this is my protons. These are always going to be that. If I subtract, I get my number of neutrons. 3 minus 1, that's 2. So I've got two neutrons. And my charge, which is a plus 1, chemists don't write 1 if they don't need to. Get used to that, we do it all the time. But this positive 1, that's going to be my protons minus my electrons. Well, let's see. If I take my plus 1 and I put in my number of protons and I subtract my number of electrons, well, electrons got to be 0, doesn't it? 1 minus 0 is 1. And that makes sense, right? Because if I've got a proton, a single proton with a positive charge, and no electrons to cancel them out, my charge is going to be a plus 1. Let's try another example here real quick. Let's say we've got, let's do do calcium. A calcium ion. What's the number of protons, neutrons, and electrons in this one? Well, let's see. If I look up calcium in the periodic table, I'll notice that its atomic number is 20. Right away, that tells me the number of protons. This is the mass, minus 20 for the protons' contribution to the mass, gives me 20 neutrons. And then my number of electrons, looks like we got a shortage of electrons here. And if the charge on the calcium was neutral, well then I'd have to have 20 protons. Excuse me, 20 electrons. So I got 20 protons that are positive. If this thing was neutral, I'd have to have 20 electrons to completely balance it out, right? 20 positives and 20 negatives, those are going to cancel out. It looks like I have a net positive of 2, which means I'm going to have 2 less electrons than 20. That gives me 18. If you want to do the math, you know that this is going to equal my protons minus electrons. What did I do? Yep, 2. So 2 is 20 minus electron. I subtract 18 from both sides. No, what am I doing? Subtract 20. I was doing the answer. So what's that? 2 minus 20, that's negative 18. Negative E, make them both positive. Number of electrons is going to be 18, if you like doing the mathematical stuff. All right, why don't you do, there's 3 on slide number 5 for you to do. Look at those, and I'll give you the answer here in a bit. All right, in this one, let's see, we'll do it like this. Protons, neutrons, electrons. Well, let's see, we just look them up in a chart, right? Chlorine's got 17 protons. Hydrogen's got 1 proton. Uranium, you look down below, there's 2 lines below the main periodic table chart. You're going to have 92 protons for uranium. This number minus this number is going to give you your number of neutrons. 35 minus 17, that's going to be 18 neutrons here. 1 minus 1, looks like this doesn't have any neutrons. And what's that? 238 minus 92. 146 neutrons in that particular particle. And if we do the charge, here we see we have an excess of 1 electron. We have 17 protons. We've got 1 extra electron, then we have protons. We're going to need 18 electrons in this particular case. Here there's no charge, so protons and electrons should balance. And here we have an excess of 6 protons, so this number should be 6 higher than our number of electrons. So that gives us 86 electrons. That minus that should give us a plus 6.